And I have to sort of mention something right off the bat about my last name. It's pronounced Aklilu, and I've had people come up to me and use it in the form something along the lines of "No, I kill you," which is not what you want to hear from people. But so, just a little bit about what Scanimetrics is. We started off as a University of Alberta spin-off, focusing on test technology for what's called system in package, and I'll get into that in a little bit. It started about 2003. If you get my business card, you will see that we have a downtown address. That does not mean that we charge premium rates like the lawyers and accountants do, and hopefully there are no lawyers and accountants here. It's because we're facilitated at Tech Edmonton, which is one of the incubator facilities around town. And they've been very nice to us in terms of rent. We have about 15 employees here in Edmonton and have marketing reps, I guess sales reps around the world, Japan, California, Europe. And that's because we're actually originally started off as a chip company. We have over 20 designs that we've taped out. And if you look around, we don't really have any NXP LSI logic left back in the 80s. So a lot of our initial business was international. We have 17 patents, a good number in the US, and then some international ones as well. Now, even though we started off in the chip space, because we're working on system and package technologies and sort of the test side of it, what's essentially happened is we developed a third business line called Designer Sept, which is what I'm responsible for, and where we actually focus on bringing the system in package and integrated modules into the Alberta space. If you've heard about system in package, it's generally been because the cell phone guys are using it, and their volumes are tens of millions of units. And we're really kind of focusing more in terms of the industrial space and some other high volume applications, but very specific to the Western Canada space as well. So it is Cleantech, so I do need to sort of point out the rep that electronics has had over the last years. I'll just get everyone to put their hands up if you could. Just put your hands up. It's not aerobics, just put your hands up. Okay. Keep your hand up if you had a computer in the 80s. Keep your hand up if you still have that computer. Okay. So there's a point in that exercise. When Compaq first came out with their PC clones, those machines were designed. Now, this is what they were designed for, not what they lasted for. Were designed to last 15 years. No one kept those machines that long. They didn't later, right? One of the cost reductions that happened later was they went to 10 years. But there was sort of a big disconnect in terms of how reliable these systems had to be and what their actual usage was. And sort of at the beginning of the century, we really started to go with the Europeans driving forward with the RoHS standard, which focused on taking lead out of electronics production, excluding, funny enough, industrial and medical spaces. And that happened in 2003. Alberta kind of got on board with the e-waste fees in 2005, and then sort of rolling forward with trying to be more environmentally responsible. Nokia came out with their recycled cell phone just about 2 years ago. And kind of, it's interesting because we sort of have this sort of, and I'm not disparaging bureaucrats here, the RoHS was sort of the bureaucrat exercise, and where we are right now is we've got the President of the United States making comments about the environment, and in the negative light, which is sort of interesting because we can't really dodge the bullet anymore. It's sort of come onto the mainstream. So a lot of this, of course, was driven by the fact that our electronics were cycling very fast. iPods come out every year. I picked on Canon because they, well, until recently, were kind of the market leader in the digital camera space. They're releasing new models in the SLR space. I mean, their digital space is even tighter than that. Every 13 months, cell phones are really only longer because people are tied into contracts, but sort of the 1 to 3 year frame. And then computer replacements, 2 to 4 years seems to be kind of the norm at this point. So great, the sort of rapid turnover in electronics has essentially resulted in a push to bring sort of the environmental responsibility to consumer electronics, but they've excluded the industrial space and medical as well, which is kind of shocking because, when you go and look at what happens, and this is in Alberta, this is happening. We got a lot of harsh environments, and a lot of oil gas information came out today. So extreme temperatures there. We have actually stuff happening in the other space as well. For a system to last 6 months before the circuit board is thrown out is actually a long time in this space. So it's even faster than consumer electronics. And some of the high failure systems are more like 30 days. So they barely last a month and they're thrown out. And to make this all fun, there's a lot of lead in these systems. And a lot of extra lead because that makes it more reliable. I think, I'm trying to remember if there's actually any assemblers left in Alberta that do lead-free. There's been a lot of complaints about reliability. If you're familiar with how lead-free stuff is normally assembled, they use sort of a tin-blended solder, and the problems that come with it is as you take it through the temperature cycling, it develops what are known as whiskers, which essentially you start doing things like creating shorts between pins, especially if you have a lot of high-density pins in there. There is work in terms of trying to create non-conducting whiskers, but from an industrial space, I mean, the moment you said lead-free to an oil guy, he runs away. That's just the sense that there is in that. So what have we been doing that kind of helps get away from this problem? Because essentially what we're trying to do is look at it from the point, how can we make these systems smaller, not losing functionality, just make them smaller, and how can we take lead out of the process? So this is, now I have to admit, these pictures were taken last week as I run around the lab with snapping pictures. This is an exercise in reduction, which essentially we're looking at going from these two systems right here, and that one there, into this. Now I have to be honest and say that the crystal obviously is not on there. And if you look at the scale, we're looking at just under 2 inches for these boards, which is normally considered sort of a small system. But we're going down, and it's a 10 times reduction in terms of what's finally done. And how this technology essentially works is it's taking the chips out of the packages here, right, and there's another one there as well, and essentially just putting them directly on circuit boards. And I wouldn't call this a system in package. This is more like an integrated module. A system in package would actually go ahead and take the system and actually put it in a package. So you go from having a multi-package solution to a one-package solution that can still keep the same functionality. I didn't actually intend this to be a plug for ACAMP, but it's kind of nice to see the LTCC line coming along nicely, because what it has in the process is they have integrated passives. A lot of the time when people are soldering onto boards, they're not actually chips, it's the passive components, the resistors, the capacitors, inductors that go on there. And ACAMP is working on integrating these into a ceramic. This is a ceramic that we actually had in our lab. We're doing some environment sort of temperature testing on it to see how it performed. Because we can't lie, so our projects are coming from the oil space, and there's a lot of interest in extreme temperatures there. Now these black things that you actually see up here, just check my time for a moment because I'm sure people are starving by this point, are resistors. You can also embed capacitors in this process, and inductors might be technically possible, but they'll make it on the large side, and the ceramic is about 2.5 inches on that spot. Now, being in the industrial space, you're kind of going off and beating up these systems. So even though you're doing these reductions, the expectations that they're reliable is still there. And actually, sort of an integrated module, and more so a system in package, would be more reliable than a PCB circuit board that has components mounted on it, because our sort of the portion of the technologies, not necessarily with the price, but with the performance, is a silicon-based wafer style, which essentially allows you to take all your passives in the system and put them into the backplane. What that means is that if you had a system that had, say, 80 passive components in it, and you had 2 or 3 chips, you could actually reduce that to just 4 components, which would be your chips, the passive backplane that would have all the resistors, capacitors integrated into it, and you've really gone from having 80 failure points to just 3 or 4, and really none, because those are epoxied on a nice rigid structure. So of course we put these in our environmental chamber. You will notice ACAMP's logo right here in the corner, one of our equipment providers, and essentially beat the thing to death to make sure that yes, it will perform in the space. Because as we send components up from the lab, we start off from the test side, so we're very focused on making sure that what leaves the lab works. So we're spend a good amount of time beating them up. It's actually kind of fun because you get, depending which scale you're on, if you're cooling the system, then you get ISO for everything, and it makes a good show when people come for a tour. In terms of, don't touch that area, your fingers will fall off.